Welcome back. Our next speaker is Gabriel Concalves Riviero, and his talk is entitled Agent-Based Modeling Methodologies for the Analysis of Complex Ancient Trade Systems. Gabriel is a student of Daniel Barreros. He has a bachelor's degree on defense and international management, a master's on international political economy, and he's currently a doctoral student on international political economy, all at the Federal University of Rio de Janeiro. Gabriel, the platform is yours.
Hello, thank you very much. Can you hear me? Yeah. Okay. So I also recorded my presentation, and it seems the quality was decent. So I will share with you the recording, and then after that, I am here for any questions. All right. Daniel, you muted yourself. Some of the most common native softwares are Network, Readable, Brave, Mass, or there are various softwares, but I will focus on Network here because common more needs experience to what I have. And number two, it's also quite simple to get started, especially if you already have some revenue. It's also quite versatile because it has plenty of documentation and functions that you can import for your research and that are publicly available. Right. So another advantage is beyond the possibility of the background which I have is that the cyclical dynamic in which the model will be impacted by selected data, and the data will be impacted by the model we choose. Gives us it's an advantage, but it's also a challenge. Still, it allows us to better visualize how information and interpretation of certain information all hand in hand and influence each other. So it's, well, I won't say that it's impossible, but it's pretty difficult to take this cyclical dynamic. But I also think that it leads to a more appropriate, to a more detailed set of research set up for. And also, since it's such an important piece of the research, one also has to be quite expressive and detailed about the how we are thinking about model, how they made the model, which data is like, why it's like, how they deal with this data. And there's all this, it forces the research to be a little bit more, yes, how can I say, the thought process becomes more fluid. Let's see what else. Another advantage of vision-based modeling, and this is a far more common, is that it can be far more simply and easily understood compared to mathematical modeling. Mostly because vision-based modeling is closer, it's much closer actually to natural language, to the and that's the goal of vision-based modeling. But the presentation of vision-based modeling, which I bring here, it's also quite intuitive. It doesn't necessarily require equations and mathematical symbols to so it's far easier to learn for someone who's not necessarily as doesn't necessarily has such a strong background in that. And it's also easier to visualize the information and how it changes. In this case here, I got this from the official article site. It's a movement model, which is a model that calculates the area of influence of a noun in relationship to other nouns in a specific area. This is also parts my vertical model because we have an actual map and it doesn't have actual geographical states. But the nouns are represented by these dots, by these circles, and their areas by the color shapes. So one reason is that how many nouns they want, they can once they set up, they can also appear on that, but we will not really do anything on the process. But once you begin the process, the simulation, you can render out nouns, for instance, simulating the fall and rise of new town or new settlements, and the areas will be updated. And you can also above the map, there will be a decide the speed of how fast the model is updated. I did it's available. And this is again just an extremely simple model that can be controlled. So you can see how for more complex such as the accent model here, which in this case it was not made with a goal, but it can be. This visualization is far more intuitive and easy to access. So, but we use agent-based modeling and we use but how will we use it? Well, to deal with the data, to insert the data into the program, into the software, we need to adapt the data into a model. We need to insert it into a mathematical model first. Well, usually it's a mathematical model, and that mathematical model will be translated to the agent-based model, right? So it's I say mathematical model, but it could be, for instance, just a logical model or something else. I wrote two of some widely known models to give examples, because if I were to bring all of them, oh, that would be possible, and the presentation would be hours and hours of me to actually have to be the entire course. So I brought the central place theory, which is one of the most widely known. It was first transmitted by Bristol in 1933, and basically it explains the spatial distribution of settlements, something closer to what we are seeing here, but it explains how one should consider this, how one should interpret this. It's used in learning logic for a variety of different objectives, and these objectives are organized in different schools, as you see here. The theory explains the spatial distribution of settlements, and for archaeology, it focuses on central places. These central places, they are spots that offer services, not necessarily services in the economic sense, but more like functions to the society surrounding them. And so it's calculated that the society within specified business to the central place will flock towards it and will be affected by it and will be influenced by it. So these functions can be, for instance, political organization, law, security, trade, infrastructure, religious, sites of worship, or well, any other kind of collective functions that either modern or pre-modern society. Right. So how is this theory interpreted by different schools? The English school, which was one of the first to adapt the single place theory, which is a theory towards archaeology, it uses the single place theory to reconstruct theories through the chronological patterns, as I explained about this image. The Scandinavian and the North German school, they use the theory to propose connections between archaeological sites. So they calculate, for instance, what this site right here would have to offer, and what this other site would have to offer, and how they would deal with each other based on distance, on the geographical characteristics of their setting, of their needs related to each other, and of the area they are influencing, for instance, and other kinds of characteristics. South German school, it interprets the central places as points that provide specific functions to territories surrounding them. So it focuses not necessarily on the relationship between different settlements, but on how one settlement projects its influence towards a wider area based on its size, on its available infrastructure, on its available functions, and how those relate to the culture, not necessarily the material culture only, but the culture, social dynamics of the communities that surround. The accent model is it's kind of a child of the crystal theory, and it focuses on generating a hierarchy between different settlements and their territories based on population size, area of influence, political mapping, and well, in this case, political mapping is not really what is the base of the accent model. It's more methodology used in terms. But even then, one would require the historical knowledge of the context of the time to understand how the determined. Here I brought an example of a research by method. In in which it generated different sets of extant models for terrestrial only trade and for maritime trade for the city of Knossos in Crete. So depending on the speed of trade and the distance between the settlements, the hierarchy between the settlements changes, and you can see that Knossos becomes more and more prevalent in both what in different settings and in different conditions. All right, so now that I have explained briefly how we can utilize models to interpret data for not really any kind of general research. How long would do that specifically to do with ancient trade? The same kind of historical research, I would say. Some settings will provide us with written records, while others will provide us with real-world and second-hand accounts by historians of the period, or just genetic traces of trade. So, yes, forgive the background here. This should be all. So, which model will we use, and how you select the data ultimately falls on the specific setting and context you are studying. In other words, there is no specific preset and widely renowned equation or set of rules to apply it. Ultimately depends totally on the setting and the context that you are going to study. Now, some ancient-based models, I wrote some of them here just to illustrate what they can be used for, specifically for the trade analysis of ancient trade and other dynamics in pre-modern societies. There are models for simulation of pottery trade and pre-colonial. This is one of the most popular settings for a model. There are also models on how kinship and relationship affect trade, models on how the Celtic populations grew during the late Iron Age, models for the Brazilian trade during the classic Maya period. There's also another research I didn't bring here, but it's about the political development in the sense of political hegemony being created in the Titicaca Lake before the Inca period. In other words, how one settlement became prevalent above all the settlements and how it became control of regional politics in the Titicaca area. So again, why not mathematical models? Because despite mathematical models being usually used to form the bridges between data and analysis, so in other words, we could be satisfied with the mathematical model to explain something. The agent-based models, they are more instinctive to understand, they are easier to understand, to visualize, and they also present the possibility of following many different integrations step by step. So you can either, for instance, generate hundreds of iterations of settings in different variables and check how the scenario will be changed, or you can generate 10 iterations, for instance, or 20, and follow them step by step to see in more detail how the agents will be, right? And that's quite useful for the analysis of patient trade. Transferring the model to software is also a relatively simple task. It's more a matter of translating the logic and the values of the dynamic model to the programming language. So it's far simpler than generating the model. Research on the subject, so I just wanted to do that will not be my lack of knowledge of more specific points of this. So these are the references I use, and well, that's it.
Thank you so much, Gabriel. Thank you. Are there any questions? Any questions from online, from Zoom?
I would like to ask
Sure.
Gabe to speak a little bit more about his research, his current research, the PhD.
Oh, okay. Thank you for the question. So my current research is using these kinds of models as a methodology, and I believe the audio quality made it a bit difficult to understand some of the explanations. But basically, I'm going to make a model of pre-Columbian trade between the a people of current Western Ecuador and current Western Mexico, and use these models to approximate data that we already have based on how they traded via the Pacific Ocean to generate more information and the most probable sets of data about these kinds of trades they performed. So, and I'm going to use, besides the models, I'm going to use the ethnographic and the historical descriptions of the social and material cultures. And yeah, that's it. My objective is to use these kinds of modeling to, well, generate a description, an approximate description of trade and economic life in pre-Columbian societies, at least in these two peoples and within this context of the specific trade in which they traded mostly silverware and metallurgical equipment and knowledge uh, for a kind of oyster that grows on the warmer waters of the Pacific, which were used by religious ceremonies for the Andean peoples. That's the research.
I have a question. I have a question actually. Will you be using specimens from museums for the oyster research, part of it?
I don't really have them at my disposal now. If I could, I would use them because it would be interesting to use to analyze, for instance, the where these oysters were available at the time. There are already some research that focus on that specific subject, and they generated a map, and it shows that there are few clusters of that specimen of oyster that are available along the Chilean coast, the current Chilean and Peruvian coast. But for the northern part, for Ecuador and the such, it's a little bit difficult because they require warmer, uh, even warmer water to grow. So they were, at least at the period of time, that's the calculation. They were mostly available on the northern uh, coast, closer to Central America and southwestern Mexico, more or less. But I still don't have the specimens nor access to them. I could have access to them probably if I went to Mexico or something.
Very interesting. Yeah, as a biologist, I would be interested in that. But thank you, Gabriel, so much. Thank you. Wonderful.